Hi friends, welcome to my channel Go Cool and Be Cool Big Data Hadoop Examination Tips and Tricks. So we are learning the big data journey. So this course is how to do the Hadoop programming, the full course in English. So we are going to talk about data engineering and then Hadoop tutorial with the map, reduce, HDFS, Spark, Flinks, High, then HBase, and then MongoDB, Cassandra, and then Kafka plus more. Are you ready? Yeah, welcome back. So big data Hadoop examination tips and tricks. So we are going to see the programming of how Hadoop is designed. So we are going to talk about all these MongoDB, Cassandra, then map reducers, and then Hadoop engineerings and everything. So we are going to see one by one. Please understand, my dear friends, since it is a programming, so please do a lot of practice. So practice is only going to help you, how the sets supposed to be available, just to bring such a kind of beautiful visualization of graphical representation and everything. So let's see one by one. Data engineering and then Hadoop ecosystems tutorial. So we need to understand. So this tutorial will guide you through key components of data engineering and then Hadoop ecosystems, including MapReduce, HDFS, Spark, Flink, High, and then HBase, MongoDB, Cassandra, Kafka, and more. Each section provides a summary of these tools and technologies as focusing on their use. So in data engineering pipelines. So I will just brief about what is the main Hadoop distribution file system, that is the HDFS. So let's see, that is the glimpse of what is that HDFS systems talks about generally. I'm not going into the depth because my intention is to bring you how the interview is supposed to be and then how the examination is supposed to be, that part. So understanding of these HDFS systems will take some time. So you please learn it and then go to practices, make some beautiful examples of a database which is readily available in the open social media. You can catch up all the information, then you can practice one by one. So then you will understand. But my purpose is how I can make you more comfortable in writing the examination, getting the certificate. You feel that very much pride to go for the next upgradation and then promotion. Okay, let's see that HDFS. HDFS is the foundational components of Hadoop ecosystem designed to store and then process massive data. That is the amount of data across clusters of commodity. However, it provides the highly scalable, then fault tolerant and distributed storage solution. So we have this kind of HDFS systems available. That is an overview of HDFS architecture. So many kind of things. We will see one by one. So HDFS Hadoop systems talks about the elephant, because a very big database it is handling, so it talks about everything. So what is Hadoop? An open source software platform for distributed storage and then distributed processing of a very large data sets. So on computer clusters is built from commodity hardware. So that is the Honda works. We have the comments from that. Then Hadoop history is Google published the GFS and then MapReduce papers in 2003-2004. Yahoo was building Nutch, so an open source web search engine at the same time. So Hadoop was primarily driven by down cuttings and then torn while to 2006. It's been evolving ever since. So why Hadoop? That is data to dawn big, so that is a terabytes per day. So vertical scaling does not cut it. So dig seek times is the hardware failure processing times, and then horizontal scaling is linear. Hadoop, it's not just for batch processing anymore. External data storage, we have this MySQL, Cassandra, and then MongoDB. So these are all the combinations of all those kind of elements we have. So to talks about external data storage, it's like server, something like that we can say. So query engines we have, so similar to Google, so we have a lot of query engines like Apache Drill, we have Yawk, Huge, and then Presto, and then Phoenix, and then Apache is also available. So these are all the query engines. So now it will talks about these symbols as represents for understanding of this handling big files, and then by breaking them into blocks, that is a map reducers we have. So we have to bring it to the structured way of storing the data stored across several commodity computers. So HDFS architecture is name node, we have data. So lot of distributions is being done. So from reading the file, how it does actually, client node, so name node we have, data node we have, so it is capturing all of information. So it will talk about, like, we have a set of data available here, A data, B data, C data. So it will collect all the data. So and then based on that, it will go for reading the file and then writing the file also. Here you see blue color, it talks about client node, it giving information, like name node is also giving, and then data node, and then it is integrated, so that any information, any dependent information, it can be captured very easily. So backup metadata, so name node writes to a local disk and then NFS. So secondary name node is maintain merge copy of edit log, so you can restore from anything. So then HDFS federation, that is each name node manages a specific name space, so volume. The high availability is hot standby name node using a shared edit log. So Zookeeper tracks active name node. Uses extreme measures to ensure so only one name node is used at the time. So we'll see, like, one by one. So in the dashboard, you can understand what is mean by HDFS. UI, that is a user interfaces. Ambari software, we are going to use the command line interfaces, HDDP and then HDFSs, proxies, Java interfaces, enough ways we are going to see that. So this is how it looks like, the Ambari sandbox. So HDFS, we have yarn, MapReduce, TAS, high base, pix, scoops, and then OZ, Zookeeper. So many kind of the things as we have. So we have to link the data. Data is very important. This is a summary of what is being said and then what is being here talks about. So name node, and then name node, data node status, NFS gateways, and the name node uptime, that is a heat. So what is the heat map range and everything, and then disk remaining, and then block. So this is the overview of the what all the set programs we have especially, and then what is the base of the software. So how we have utilized so far, and then what is the space remaining and all. So the next one is the heat map we have. So after the analysis, once you go for, yes, we can go for processing the data. So it will give you the structure of the analysis and everything. Configuration, like, we have configurations of data, where to where, linking of the data, x-axis, y-axis, dependable, non-dependable. So many kind of things as we have, like, we have to make our these systems to read the data, structured data and unstructured data, semi-structured data, so that we can able to capture all those kind of information. So this slide talks about the dashboard in the preliminary stage. And now, so this is the file preview. So we are going to talk about the entertainment. I will explain you, like, 196 to 42.3. So next we have 4499 digits we have. So what it talks about generally. So file preview, this is also, we can say, it is a structured data, so where we can download. This is the entertainment of the movie, like we have a collections of movie from Netflix, I think so. This is how it looks like, the decoding of the data. So it's very difficult to read, I think so. Yes, so let's go one by one. So we have to take all the data, so from the main file to this overall system. So this is the database where it is saved. So database is talks about, like, size, and then permissions also available. Everything we have to make it into the system. So now let's see, like, first we'll understand what is meant by MapReduce. So then we will see the examples of entertainment. So how does it work? Hadoop, there is a MapReduce. So introduction, MapReduce is a processing modules in Apache Hadoop project. So Hadoop is the platform built to tackle big data using a network of computer to store and process data. Because what I'm talking about here is the first two videos. We'll talk about the course introduction, and then what all the things we're supposed to do in this Hadoop programming and everything, before jumping into the main content of answering the question as well as the finding the answer. So my intention is very clear. First, I will make you to understand what is my big data and how it works first of all. So how the program is set behind this, so that you can easily feel comfortable in attending the examination as well as the answering the question also. You will understand, you can at least directly take it so from the learnings that you have done, so in these videos particularly. Okay, affordable dedicated services we have, so are enough to run the cluster. So you can use the low cost consumer hardware to handle your data also. So Hadoop is highly scalable, so you can start with the with as low as one machine. So and then expand your clusters to an infinite numbers of servers. So the two major default components of this software library are MapReduce and then HDFs, that is Hadoop distributed file systems. So in this article we will talk about the first of two models. So we will learn so what MapReduce is, how it works, and then what is, and then the basic Hadoop MapReduce technology. So this is how it looks like. That is the input of data we have. So map will go for the reduction, and then output also we have in a single format, that is a prescribed format also available. That is the HDF, so distributed systems it does. So what Hadoop MapReduce? That is a Hadoop MapReduce programming models facilities the processing of big data stored in HDFs by using the resources of multiple interconnected machines. MapReduce effectively handles the large amount of structured and unstructured data. It's not semi-structured data first of all. So before Spark we have, so under another modern framework, this platform so was the only player in field of distributed big data processing. MapReduce assigns a frame, others fragments of data across the nodes in Hadoop cluster. The goal is to split a data set into chunks and then use an algorithm so to process those chunks are at the same time. The parallel processing and then multiple machines so greatly increases the speed of handling even peta types of data. Distributed data processing apps, in the sense like this frameworks allows for the writing of applications for the distributed data processing. So usually Java is what so most programmers use, since Hadoop is based on Java only. So Java programs, we have multiple levels available, so the background is being on Java is programmed. So however you can write MapReduce app so in other language such as Ruby or Python, no matter what languages a developer may use. So there is no need to worry about the hard work that the Hadoop cluster runs on. So this is how it looks like. So scalability, we can see, I'm not going into the deep, like you can read out each and everything, for example your understanding also. I would like to show you the script of Netflix, like how the data is being captured. So now before going to this, first I will like to make you MapReduce how it works. First of all, at a high level, MapReduce breaks into the data into fragments and distributes them across different machines. The input fragments consist of a key value pairs. So parallel map stocks process and then chunk down data machine cluster. The mapping output then serves as input for the reduce stage. The reduce stocks combines the results into the particular key value pair output and writes the data to HDFs. So basic terminology of Hadoop MapReduce. As we mentioned about MapReduce processing layer of Hadoop environment, MapReduce works as task related to the job. So this idea is to tackle large request by slicing it into smaller units. So now let's see the job trackers and task trackers we have. So for example Hadoop 1 and then MapReduce we have. So it job trackers, like it talks about task trackers as well as the task discussions of the job also. So it will give the interconnected systems available. In the early days of Hadoop, that's a version 1 job trackers and then task trackers so ran operations in MapReduce. At time Hadoop clusters could only support MapReduce applications. The job tracker controlled the distributions of application requests to the compute resources so in a cluster. So since it is monitored so the execution and then status of MapReduce, it resided on the master node. A task tracker processed the request that came from the job tracker. So all task trackers were distributed across slave nodes in the Hadoop cluster. What we have seen in the distributed file system is that is Ambari, Yarn. Later in Hadoop version 2 and above, Yarn became the main resource and scheduling manager. Hence the name yet another resource manager. Yarn also worked with other framework for the distributed processing in a Hadoop cluster. MapReduce job, what it does generally. MapReduce job is the top unit of work in the MapReduce process. It's an assignment that map and reduce processes need to complete. The job is divided into smaller tasks over a cluster of machines for faster execution. The task should be big enough to justify the task handling time. If you divide a job into usually small segment, the total time to prepare the split and create task may outweigh so the time needed to produce the actual job output. So map reduce task, we have map task and then reduce the task. So map task reduce the tasks, it will give the reductions of the multiple components as we have. So it will easily identify 1 2 3, then it will identify capturing of the data very easily. Okay, let's see. I'm not going to the depth. The Hadoop map and then reduce work together. So for example, this is the input data. So HDFS systems we have. This we have, for example, 6 files we have. So map stage, it will allocate, it will split into 2 2 2. So then map allocation. So for example, Apache 7 and then class 8, track 6. So this is the map that is a split to 1. The next one is a map Hadoop 10, class 10 and then track 16. Map 15 and then map Hadoop 10. So this is the 3 stages we have. So how it reduces the stages? That is a shuffling of all those things. As the orange color talks about Apache family. Apache 7 and then Apache 50, it will distribute Apache, then it will reduce to 2 2. The summation of 7 plus 15 is 22. So then it will become Apache 22. That's all. So once Apache 22 means it will collect all the inputs as wherever it is applicable. Now coming to green, track 16. So this green is talk about 16, so it is 22. So track 22. So similarly we have class 18, Hadoop 20 also. This is how it reduces a lot. So that what will happen, automatically system will capture the data exactly so what it needs. So here again we have a lot of information, first in the map stage. So the input data, so the 6 documents, that is what the split up is given. So what we could understand in the previous picture. So the explanation is given in this, so you can at least to go ahead for better understanding. So now finally the Hadoop partitions may input data. So now we will see the conclusion. The challenge with the handling big data was that the traditional tools were not ready to deal with the volume and complexities of the input data. So that is where Hadoop map reducers came into play. So the benefits of using map reducers include parallel computing, error handling, fault tolerances, logging and reporting. So these articles talk about especially how the things is working behind this. So why map reduce? Now let's talk about this one. Distributes the processing of data on your cluster. So divides your data up into partitions that are mapped, transformed and reduced, aggregated by mapper and then reducer functions as you define. Resilient to failure, and applications as masters, monitors as your mappers and reducer on each partitions. So let's state with an example what we have discussed about. We have a lot of Netflix films as Finding Nemo, Lion Kings, then Toy Stories and everything. So how it has been designed? Let's see the examples as movie lens data. For example, user ID. For example, you are seeing the movie, myself I am seeing the movie. So we have been defined as ID 196. So movie ID is 242, 302, then 377. I am giving the rating 33112. So this is the time AMP, that is timestamps we have. Map reduce sorts and then groups the mapped data, shuffles and then sorts. So how it looks like 196, then 242. There is a grouping of data 186, 302, 196, 377, 244, 57, so like that. So then again it will come to 166. So 346, that is the overall stages we have. So 1 2 3 4 5 6 7. So 7 entries we have. So 1 2 3 4 5 6. So and then we have 1 346, 186. So we have two entries available. So 302, sorry, three entries available: 302, 274, and then 296. And then again 196, it becomes like, we have I think one and two entries available: 242, 377, 244, only one entry is available. So how we can reduce with minimum? So the reducer processor, each key's values. Now 166, it talks about 346. So 166 means we have only one entry is available. So 346 only one entries. 186, so we have a three entries available: 186, 302, 474, and then 263 entries. So this is how we can come to the end, like how it has been reduced. So putting it all together, like user ID, so then map, reducer, shuffle, and then short, and then reducer, how it is being reduced. So this is how it will understand. 166 is only one entry. This is three entry we have, and then two entry we have, and then one entry we have. This is how the map reduce is working. So to make the data is very safe. See, writing the mapper, how it looks like. See, now let's see that user ID, movie ID, and then rating, and then timestamps we have. So then mapping of all those information. So three entries we have, and then one timestamp we have. So 196, 242, 3, the three entries is, and then 196, 242, and then three entries we have. So this is how it looks like: 3, 3, 3, 1, and 2. So here mainly the mapping we are doing movie ID. So movie ID 3, 3, 3, 1, 2, 2, and then 1, 4, 2. So these are all single entry we have. Shuffle and short. So how we are doing? So 3, 3, there is no any 3. No, yes, only 1. So 1, how many ones we have? So 1, 1. So this is the two entries we have. So 2 entries we have. 4, only one entries we have. So how short we can bring it? Now again we will put it to reduce 1. So we have a 2 entry, 2 entry, 3 2 entry, and then 4 only one entry is available. So def mapper, so get rating. So this is how the coding is being done. So user ID, movie ID, rating, and then timestamp, line split, and then so we can reduce this yield ratings and everything. Now putting it all together, so from some job to job import JMR jobs. So and then again we have to step import the data. So this is how the looks of coding to capture the data, so that it will give informations to this Ambari software, so to get the visualizations of the data. Now let's understand about the architecture. HDFS follows the master slave architectures, as where it has. So before going into the depths, we will understand about name node, that is a master, manages the metadata. So such as the directory structures of the file names, block locations, permissions, and other file attributes. So data nodes, slaves, these are the workers. Nodes are responsible for storing the actual data, so in the form of blocks. So each file is divided into blocks and distributed across different data nodes in the cluster. So blocks, and then block size. What is meant by block size? So files in HDFS so are split into fixed size blocks, usually 128 MB or 256 MB by default, and stored across data nodes. So this large block size is designed to reduce the overheated of handling small blocks and improve data transfer rates. Advantages of blocks: so fault tolerance we can see, scalability is also one of the main areas, and then what is the replication? HDFS maintains multiple copies of replicas of each data blocks across different data nodes to ensure fault tolerance. So replication factors, we have replica placement, one replica on the same node where the data originated. The second replica is placed on the different node in a different rack, so no to the prevent rack failure. The third replica is replaced on another node, so in the same rack as the second replica. So fault tolerance, we could see HDFS is designed to be highly fault tolerant. So data node failure and then name node failure also one of the main area. So why the data node is lost? When a data node is lost, the name node re-replicas the data blocks on other data nodes to ensure that the replication factor is maintained. So this self-healing feature nature. So this healthy nature of HDFS is what makes for it reliable for large scale data storage. So data write, read operation. So writing the operation. So we have a code. The client send a write request to the name node to create new file. The name node checks for metadata. So and allocates the set of data nodes for storing replicas of file blocks. So file blocks. The client then split the file into blocks and then writes each block so sequentially to the data nodes. So data is pipelined to the multiple data nodes based on the replication factor, ensuring all replicas of a block are stored. Read operations. A client sends a request to the name node to read a file. The name node returns the locations of the name data nodes that fold the blocks of the file. The client then contacts the nearest data node based on the replica location to read the data. So data is streamed from data nodes for the client for the faster access. So rack awareness we have. So rack awareness helps HDFS make decisions on block replacement, ensuring that replicas are placed so in different racks to prevent data loss in case of rack failure. So network topology. By storing copies of data on different racks, HDFS reduces the risk of data loss due to simultaneous failures of all nodes within the single rack. So high throughput, the scalability. HDFS is designed to handle large data sets, so from gigabytes to petabytes efficiently. So data processing, we have horizontal scalability, and then data integrity, we could say that secondary name node we have. So FSL image and then edit logs, so which we can able to same additional of this primary name node as well as secondary name node also. It periodically merges the name node. That is the specialty of this one. So with the file names image, preventing from the log so from growing indefinitely, and ensuring faster recovery times in case of failure. Limitation of HDFS. So small file problems, then balancing. HDFS is insufficient as when dealing with millions of small files, as each file, even if small, consumes a significant amount of name node memories for metadata. Then latency. HDFS is designed for high throughput and not low latency data access, so which may not be suitable for real-time application. Then name node as a single point of failure, so SPOF. So then use cases, we can see HDFS primarily used in scenario requiring storage of large scale. That is a log storages and analysis, data lakes we have, data processing, and then ETL pipelines to capture furthermore. So this is how it looks like. We can pack Apache Storms we have, and then Hortonworks, and then Presto. This is Spark, Hadoop, Apache Super. So many kind of things as we have. Now core Hadoop ecosystem. So this is how it looks like. So we'll go one by one. Just I will read out. You can understand before going into the programming of visualizing the Ambari software, and then we can go ahead further. We have lot of things as like MapReduce, Yarn, HDFS, and then Apache Storm, Kafka, data indigestion. So this is how it looked like, my dear friends. So Hortonworks, we have lot of sandboxes available. Like we have HDFS disk usage, data nodes live, then HDFS links, memory usage, network usage, CPU usage, cluster load, name node heat, and then name node RPC, name node CPU view, and then name node uptime, HBase master heap, HBase links, and then load, and then master uptime. So resource manager heap, and then resource manager, then node manager live, and then yarn memory, and then so once we update the data, so from the data sources, and then a lot of files we have. So once you start updating and giving the programs as background, so you could see that in this dashboard especially. So if it is wrong in the sense, it will give in red color. So if it is in the pipeline, so you can able to see lot of things is available here. So the look of this name load and then calculations of name node RPC is just 0.13 milliseconds. So just we have to upload the data, then we can make the correction of movie ID, name, and then column 3, column 4. So what is the starting rating of everything. So successful completions of data, we have to make the programming of a database explorer, that is a query. We have to write the queries and everything. So this talks about movie ID, name, column 3, column 4, columns. So many kind of varieties as we have. This is the file name, user ID, movie ID, rating time. So we have to merge by writing the movie. So worksheet, select movie ID and then count movie ID as rating count. Then from rating, group by movie ID, order by rating count. So and then we have to write the description. My dear friend, this is how it looks like, movie rating count and then movie ID. So movie rating count is very low in this population, first of all. So and then movie rating count is very low, but movie ID, when it talks about this movie, is giving her a lot of insight, the rating is also very poor. So we have to understand the rating count is very high populations we have. So in this reference we can identify a lot of significant populations we have, because a lot of customer used to put their ratings. So accordingly we can catch up all the heat map. So here we could see the population, we can correlate what is the movie ID and then what is the rating count is also available. So here all we have a selection of files and everything. So this is how it looks like.
So finally, let's learn and level up ourselves, and let us help and support others. So without pain there is no gain. I hope you like this video. So please give your valuable comments so that I can also level up myself, and share to your beloved ones. So thank you very much, and thanks for watching.